Okay, assalamu alaikum everyone, and welcome again
Walaikum salam.
to another session for EEE 6307. So in the last class, we actually started the topic of dynamic modeling for governor system. And specifically, we were talking about the fly ball governor, the mechanical governor system. Okay, so we started the discussion, and if we have a quick recap on whatever we discussed in the last class. So we started with the discussion on this part, which is a reference set point controller, where if we lower it, okay, or if we want to have our set point or power set point PDEF lowered, okay, then this notch has to be moved up and vice versa. Okay, if we want to have a lower reference set point or higher reference set point, then we have to move it downwards. So this was basically this movement of this arm, which is actually attached to point A here of the arm ABC for the flyball governor system. So that point is attached to A, and until and unless we are moving this point here, A would remain fixed. So then ABC was part of the an arm where B is the pivot point, and CDE is another arm of the mechanism, flyball mechanism, or this governor mechanism, where D point is another pivot point for the part CDE. So then we discussed a certain scenario actually by keeping point A fixed. What we did, we talked about, let's say if there is any variation in the speed from the steady state operating point, let's say we have a reduction in increment in the load demand or reduction in the load demand, then correspondingly PE has to be changed. And at the same time, we have to make sure that that change is actually accompanied by the corresponding input mechanical power. So if there is any change in speed, that is the shaft speed from the synchronous value or the steady state operating value, so that would be sensed here by the lower part of the shaft, lower part of this part, and accordingly we talked about two forces, two oppositely acting forces. One is the spring tension. So the spring tension force, these are the two fly balls. So we talked about some centrifugal force and spring tension. So we talked about the Fs and Fc. Okay, so Fc is the centrifugal force and Fs is the spring tension. And whenever there will be any variation in the shaft speed, then these forces would be changing. Okay, these two forces would be changing. One would be going higher than the other one, at least for a transient period of time. And accordingly, this distance, whatever distance is there between these two fly balls for a certain steady state operating point, that point or that distance will be disturbed or changed. This distance will be changed. And once this distance is changed, that change would be translated as the movement of the upper part of the limb here, upper part of this whole thing. So accordingly, you will have a lowering of point B or moving up of point B, okay, raising of point B. Considering, of course, point A is still fixed. Point A is fixed. So if B goes down, then accordingly, as point A is fixed and B is the pivot point, so C would go down. So this was the discussion probably up to this point we discussed. Okay, how the movements of B, C, the shaft speed, the fly ball positioning, or the distances between the distance between the two fly balls, the spring compression or expansion. So all these things were actually discussed. We stopped actually our discussion up to this point, point C. And then we said, well, if let's say if B is moving down, then because C is a freely moving point. Okay, it is not attached to any other part of the system. So if B is moving down and A is fixed, so C should move down. So if B goes down, C should go down, considering that A is fixed. Now, let's move on. So if C goes down, then what would happen? Okay, so now we have to look into the piston valve position of piston valve within this chamber. Okay, this whole chamber from starting from here to here is known as the hydraulic amplifier. I already mentioned it in the last class. Hydraulic amplifier. Because the input force to this block is smaller compared to whatever output force is obtained or output force is transmitted to this main valve. So in a sense, it takes in a low input energy and it converts it into high input energy, okay, or high output energy. So that's why it's known as the hydraulic amplifier. And why hydraulic? Because this amplification is done due to the flow of this high pressure oil through the chambers, okay? So because of the media or medium through which this amplification is done, it is like a liquid medium. So that's why we call it hydraulic medium or hydraulic amplifier. Okay, so now at this point, at this specific point, whenever the system is at a steady state operating point, we can see that even if there is high pressure oil coming and entering this chamber, okay, this is the blank space, this chamber, then it cannot actually move forward because there are two probable paths for this high pressure oil to flow through. Okay, this is one of the path and this is another of the path. Both of the paths are at this current point blocked. So this would be the situation at any steady state point. This should be the position of these piston valve and the main valve. They would position themselves in such a manner that there is no gap or no passage left for the high pressure oil to move through the piston valve to the main valve. Okay, so at the steady state operating point, there are no gaps left. So even if the oil flows in, it cannot actually go into the next part of the hydraulic amplifier. Okay, it can come through the piston valve, but it cannot move up to the main valve. Okay, so it cannot actually hamper the current position of the main valve. However, as we were discussing that point C moves down. Okay, if point C moves down, what would happen to point D? Considering point E is attached to a very heavy mass. Okay, this is a heavy mass or heavy shaft. Compared to this mass, the mass of this shaft is pretty large or pretty heavy. So E is attached to that. Point E is attached to the heavier shaft or the main valve shaft. So if that is the case, now if C moves down, according to this discussion up to this point, if C moves down, what would happen to D?
It will move down.
It will move down. Excellent. It will move down. So D moves down. C moves down. D moves down. So if D moves down, what would happen to these two channels? Which channel would be opened? This one or this one? Upper one or lower one? This body will go down actually. These two blocks would move down.
Lower one.
Lower one would be opened. Excellent. So lower one would be opened. So we would see in the next slide, inshallah, that this passage would be opened. Okay. If this passage opens, this is blocked space. So the oil can only force the piston in this direction. Okay. If this passage is open somehow and the high pressure oil gets the passage, and it can only push this main valve into the upwards direction. So what would happen to point E now? If this point goes up, point E would move up. Point E would move up. What would happen to this block, it would also move up, and this passage here would be blocked a little bit more. Okay, it would be blocked and not completely blocked, of course. That means this passage of steam input would be reduced. This passage of steam input would be reduced because of this movement of the main valve or main shaft into the upwards direction along with point E. So point E will actually take the required energy from the high pressure oil, from this force actually in this direction due to the high pressure oil flow, and point E will actually take this shaft along itself. Point A will move the shaft along point E would move along with this main valve into the upwards direction. And in this manner, actually the steam input would be reduced. So what would happen if the steam input is reduced? Where would be the effect going?
It will be reduced. Shaft speed will be reduced.
Turbine energy, the input energy to the turbine would be reduced, right? Input energy to the turbine would be reduced. So PM would be reduced. So remember what was happening? The load was getting reduced, PE was getting reduced, PM was fixed until this happened. Okay, until this channel is getting smaller. Okay, until this channel is getting smaller. So accordingly, what would happen? A new balance would be established, because you see PM is getting reduced. PE was originally reduced because of this reduction in PL. The loads were switched off. You require less electrical output, but that has to be balanced by a less mechanical input. So this is how you will have a new balance between PM and PE, and a new omega would be, sorry, not new omega actually, a new, yeah, you can say also new omega steady state would be achieved, or omega steady state value would be achieved after a certain transient period of time. Okay, so now let's see, this is, I say it simply for a certain case. Now let us see it in another slide with different scenarios. Okay, so there could be actually different scenarios. Scenario number one, let's say probably something like, as we discussed already, that you could have a load reduction. This could be one scenario. Scenario two could be load increased. Scenario three could be, so in both these cases, we are not changing the reference set point. So reference setting is kept fixed. Okay, so if the reference set point is fixed, then what would happen? How would the governor react to these two cases? Okay, load increment and load decrement. These are the two scenarios. The third scenario could be now, okay, the load is not changed, load is fixed. Load is fixed in both cases, but in this case, probably we're trying to change the reference set point. Reference increased and reference decreased. So in total, probably you would look into these four different scenarios. Okay, we are treating them as scenario 1, 2, 3, and 4. Okay, so now let's see scenario number 1. So in scenario number 1, okay, so this is the statement of the scenario at the top. So we have some increment in the load, generator load. So that means if we have increment in the generator load, how would it be translated? So if PL is increased, That means now the generator has to supply more electrical energy. Okay, this has to be satisfied. So ultimately what we would need at the conclusion, if you have to supply more electrical output, that is only possible if you have more mechanical input from the turbine, right, to the generator. Or in other words, more steam is being flowing through this channel to the turbine. Okay, so this should happen ultimately. That is the finally we should get this. So now let's see whether we get this or not. Okay, so let's start. So as because PL is increased, PE is increased, but PM cannot increase instantaneously. It is a mechanical quantity, so it would take some time to change. Okay, so what would happen to the shaft speed? Shaft speed would reduce. Why should it reduce? Anyone? If the load gets increased or the demand gets increased, why should the shaft speed decrease at first? No one with the answer? Tafim?
I'm not sure, sir.
Not sure. Okay, tell us whatever you want to say. No problem.
Omega will decrease.
Why? Why will it decrease? Yeah, shaft speed decrease means omega decrease. That's fine. It's the same thing. Okay, shaft speed is omega actually. But why should it decrease? If you have PM and PE, okay, we are saying at a certain steady state operating point, let's say this is 50 megawatt. This is also generator is providing 50 megawatt. Okay. So this was the steady state operating point. At a certain operating point, you should get this thing. So d omega by dt is equals to what? PM minus PE. What do we have here? 1 upon twice H. If we ignore actually the damping power. Okay. So this is the second of the swing equation, or the second equation of the synchronous generator describing the angular motion dynamics. So let's say at any steady state operating point, the demand is 50 megawatt and the corresponding input, mechanical input, is also 50 megawatt. So they are balanced. Now suddenly we say it that the demand increases, load at the generator increases. So what would happen? Instantaneously, you are switching on the loads, right? You are switching the load, turning on the loads, turning on the fans, turning on the TVs, turning on your washing machines, whatever. So suddenly it can take the value. P is changing suddenly, instantaneously, almost within a very short time. P can jump to higher value or lower value. In this case, we are considering P is jumping to some higher value. So if it takes some higher values compared to 50, let's say it becomes 60. Now what would happen? So you will have d omega by dt is
negative.
It's some negative value. Okay, some negative value. So thus, before the increment of the load, it was 50 and 50. So there was actually d omega by dt was 0, and the system was running at synchronous speed. But once there is change in demand, so there is some negativity there, and that would give you some negative change in the omega. So thus omega would get reduced. So this is how omega is getting reduced at the very beginning with the increment in the demand. Okay.
Yes, sir.
Okay. So if omega decreases, what would happen? What would happen here?
Shaft speed will also decrease.
Shaft speed is decreasing. You see, it is being shown here. Shaft speed is decreasing. So the arrow I have shown it, it is decreasing. So shaft speed decreases. So if the shaft speed decreases, that would be sensed by the lower part here. Okay, this shaft, this part of the system. So this part senses that, well, now there is lower speed. So as we know, we have centrifugal force and the spring tension working on the fly balls. Before the imbalance, whenever there was 50 and 50, there was balance. Okay, but now we have reduction in speed. So if the speed is reduced, which of these force would be less now on the fly balls? Spring tension or the centrifugal force?
Centrifugal force.
Centrifugal force will be less. So spring tension should be higher than the centrifugal force. What that would do? That would try to bring the fly balls closer. Okay. So that means spring will be compressed because of this relation. So the spring tension is higher, that will try to pull the two fly balls closer because of this. So the fly ball distance decreases. Okay. The fly ball distance decreases. Once the fly ball distance gets decreased, what happens next? So because the fly ball distance gets decreased, so what that would do? That would actually, yeah, pull this point up. Okay, it will shrink, the balls will shrink, and that would create a force on this shaft into the upwards direction. So point B is moving up. What about point A? Well, we haven't touched it. We have not touched it. So it's unmoved. So if B is moving up, A is unmoved, doing nothing. What would happen to C? C would go up. So because C is going up, E is connected to a very, high mass, again, heavy mass. Heavy mass. So E actually cannot change suddenly, okay? It has to wait for a certain duration. There is a lag between the operation of C and E, okay? So as soon as C goes up, D is the pivot point for the part CDE. So D should also go up. It will have a force acting into this direction on D. So C will actually try to pull D in the same direction as the C is moving, along the same direction as C is moving. So C and D moving up. If D moves up, you see now the channel is opened, okay? The piston is moved into the upwards direction. So the upper channel gets opened. Previously it was closed. In this steady state point, you see it was closed. None of the channels were opened. This channel is closed and this channel is closed. But in this slide, in the next slide, here, you see what is happening. The upper chamber is opened because of the point D moving up. So the upper channel, so the next point is basically the piston valve also moves up. This is the piston valve. The piston valve, this is the piston valve, it moves up along with point D. So the upper chamber or the upper opening is actually created. Upper channel is opened. So the high pressure oil is there, it will flow in this direction. And because the path is closed there, so the oil cannot move forward or move further out of this chamber. So it will, whatever force it had, it would transfer the energy on this heavy shaft. Okay, so that would create, that would create, or that would make this heavy shaft move into the downwards direction. Okay, so with that, what would happen? This heavy shaft would move down and there will be larger opening. There will be larger opening. So much more steam can now flow through these channels or larger opening to the turbine. So the turbine would get higher kinetic energy input, and as the output of turbine, we would get higher PM. Okay. So what is happening to point E now? Again, we forgot about point E. So because this main shaft is moving down, so the point E will also move down. So point E moves down, the main valve, the main shaft moves down, steam input increases. Okay, steam input increases. So as the steam input increases, we have higher mechanical power available from the turbine unit. So as we started, like, what was the first point? The first point was we have an increment in the load demand. So the first point, we started from here. We said load demand is increased. Accordingly, generator has to supply more electrical output, and that has to be taken from larger mechanical input from the turbine side. So this is achieved. Okay, we have been able to get an increment in PM, and we hope that this balance will be again established. Okay, so let's see what happens next a little bit more. Okay, the job is not done yet. Okay, we have only increased PM. Okay, we have only increased PM. So if PM is increased, now just give you a small intro to the next step. Okay, what would happen next? So that means, let's say we say this is 60. So now let's say whatever amount of input, steam input has been increased by the opening of this channel here. So now let's say that is also 60. Okay. So if now again, both are 60 and 60. So what do you expect with the shaft speed? Remember, all these things
Will be
are,
0.
shaft speed would be 0. Anyone else? Shaft speed 0 means what? Shaft speed 0 means actually it is unmoved. So your generator is actually not running at all, right?
Yes.
So if you have any balance between mechanical input and electrical output, and if your generator stops functioning or rotating, then how would you get the energy from the generator? Have you got my point?
Yes.
So again, the same question. If this balance, okay, whenever it was 50 minus 50, what was the speed? Tafim? 0? Before the load increased, before PE increased, it was 50 and 50, right? 50 megawatt and 50 megawatt. So what was omega then? Was it 0?
There must be a constant speed.
Yes, there must be a constant speed. Actually, d omega by dt would be 0, but omega should not be 0, right? It's a synchronous machine. So at any equilibrium point, omega should come back to synchronous value. Okay, omega should come back to synchronous speed value because it is synchronous machine. So before the disturbance, before the load was increased, this was the scenario, of course, multiplied by 1 by twice h. So there was no d omega by dt because of this balance. Okay. So what was omega? Omega was equal to omega synchronous before the load increased. Now we said, well, after some transient period, after the steam input increased, before that PE was increased to 60. So then what happened? The governor system started to react to this change. And accordingly, let's say we found that, okay, now PM is also 60. So my question was, what would be the speed again at this point? At 60 minus 60.
Synchronous speed.
It should be synchronous. It should be again synchronous. Yes, very good. It should be again synchronous. So before it reached to synchronous, you see the speed was actually reduced from synchronous due to this 50 minus 60 scenario. Okay. Speed was decreased. So now because we have got 60 minus 60, what would happen again? Speed would try and reach omega synchronous, which would be of course higher than this value, whatever value was here, because it was reduced than synchronous. So when it was 50 minus 60, actually we had omega less than omega synchronous. Is it clear? Whenever it started, the load started to increase and load actually got to 60 megawatt, we said speed is reduced, right? So at that point, omega is of course less than omega synchronous, isn't it?
Yes.
Okay. So omega was less than omega synchronous. Now, when it became with the increased steam input, when it they were balanced completely again, 60 minus 60. We are saying omega is again back to omega synchronous. So what does that mean? If due to this reduction, let's say omega synchronous is 1500 RPM. So at this point, it should be less than 1500, right? Something 1400 or 1450, depending on the imbalance there, depending on the imbalance. But of course, it should be less than 1500 at this point. But at this point, when steam input increased and you have again gained this expression, omega equals to omega synchronous. So what is the speed? Again 1500, isn't it? Because that is the synchronous speed we are talking about. So now this speed 1500, is it higher than this speed or not?
Will be higher.
Will be higher. So what would happen? This increase in speed would be again sensed by this shaft, right? In the next slide, I will show it. Okay. So now at this slide, at the starting, we had, let's say 1400 RPM. Speed is reduced, let's say to 1400 RPM, and then everything else happened. And after everything happened, we got 60 and 60 here. So that means speed is again increased back to 1500 RPM. That means it is of course higher than whatever speed was here, which brought the springs together closer. Now speed again increased from 1400, this value, to some higher value, 1500. And that would be again sensed here, right? So that means what would happen to the fly balls? If you have any query, please ask. Otherwise, things might become complex. Any confusion, please ask.
Sir, I have a question.
Yes.
Where a point B and C, but it is a rigid one or flexible point, B and B.
D and B.
D.
D.
Yes, sir.
All the
Is
points
it
are flexible. All the points are flexible. Because otherwise they can't move. You see, I'm moving them. I'm saying it is moving up, it is moving down, it is moving up. And point A is still kept unchanged, but later on we will see that it can also move.
Yes.
Because if they don't
Sir,
move,
if I be moving up, then C will be up. But
no, don't go in that direction. C is not dependent on D. D is dependent on C. Don't change the sequence. So if you say in the reverse manner, it's not true. Okay. C actually control here in this case, C is change in C is actually controlling change in D, not vice versa. The sequence should be in this direction. The movement should be in this direction. Chain of action should be like this, not like this. Okay. Okay. Thank you. Any other question? So at the bottom part of this slide, we conclude that, well, steam input increases, so speed should increase, right? So in the next slide, we will start from here. We are still in scenario 1, but in the next phase of scenario 1. So speed increased in the last part of scenario 1 in the previous slide. Sorry. So in this slide, let's see what happens. So again, we start from speed increase here. Okay, speed increased. Why? Because remember in the last slide, we said PM increased. So if PM increases, then speed will consequently increase. Okay, and it increases and it settles. Ultimately, it settles to equilibrium. Okay, this is in continuation with the previous slide. Remember, it's not a different scenario. It is still scenario 1. It is in continuation from, it is the continuation from the previous slide. So if speed is shaft speed increases now, what would happen to the fly ball distance? Due to the increment in shaft speed, our centrifugal force will now increase, isn't it? Centrifugal force would increase. So you see, that would actually stretch out the springs. Springs will be stretched back. In the previous slide, you see what was happening? Springs were shrunk or compressed compared to the steady state case. This is the first slide for the first diagram before increment in the load. This was the, let's say, any specific position where some steady state equilibrium is there. Okay, look at the distance. Okay, look at the, please follow the distance carefully, the distance about the fly ball, between the fly balls. In this slide, what we said, we increased the load, so speed decreased. So in this slide, what happened? The centrifugal force, because speed decreased at the beginning, the centrifugal force decreased. Spring force was there already, and because of that, we had Fs greater than Fc. And because of that, because of this spring force, the spring tension, the spring got compressed. But at the end of this slide, we said steam input is increasing. So as the steam input is increasing, speed is increasing, and it is settling to a certain value. And for a synchronous machine, it should be a synchronous speed, synchronous machine, it would be synchronous speed. Then because of this increment in the speed, your centrifugal force again rises, and that helps the fly ball to move apart again, So you see the distance is increased compared to the previous slide. Distance between the fly balls has increased, and a spring is not compressed. It is actually stretched back. Is this clear up to this point?
Yes, sir.
Okay. So now because spring is stretching compared to the previous slide, so what would happen? Remember, A is still unchanged. A is still unchanged. We are not touching it yet. So what would happen to B? Because these points are stretching, these two fly balls are stretching apart. So this will pull the point B downwards. So you see point B going down because this distance is increasing. Okay, so point B will go down. Point A is still unmoved. We are not changing it. If B goes down, what would happen to C? Because A is fixed. So if B moves down, it will also take C along with it. So C will also go down. If C goes down, E is connected to a heavy mass, it cannot move instantaneously. So C will take point D also down. If D goes down, you see, now it will slowly go down and close out this channel. Channel is again closed. So the high pressure oil cannot actually change your piston anymore. But remember, this already changed its position, right? From the previous steady state operating point, from the first steady state operating point, you see, this is the first steady state operating point before the load was changed in slide number 12. Slide 12, before the load was changed, you see the distance here, okay? You see the distance, closely follow this distance. This distance here, this channel distance, width, channel width. And then after steam input increased, now you see the channel. You see, it moved down, right? It moved down and it created a larger opening, But now there will be no further movement. Of course, the steam input increased. You have higher PM, you have higher PE. They have a balance, PM minus P, both are same. You have omega equals to omega synchronous, but this omega synchronous is now achieved at a higher PM or at a higher PE. Okay, because now there won't be any further change in point E. Okay, so although D is moving down, it is actually closing the gap, two gaps. Both of the gaps are now closed. So high pressure oil cannot move in through the upper channel because the channel is closed due to the movement of point D into the downwards direction. So point E won't move in this case. And this shaft, big shaft, won't move anymore. But it is keeping a larger channel there, a bigger channel there for more steam to be flowing into the turbine. That means now a higher PM is there that can supply a higher PE. That means a higher load demand can be supplied from the steam input or using the steam input. So you see now the high pressure oil, this, okay, piston valve moves up, piston valve, sorry, there is a mistake. This is the mistake. Piston valve shouldn't move up. If point D moves down, piston valve should move down. Always there are some issues with copying and pasting. So, okay, I will correct it, inshallah. So this should be copied from here because point D, if point D moves down, then your piston valve should move down. Okay. So the piston valve moves down. Piston valve means this valve actually. Piston valve means this valve. So piston valve moves down. Your channel gets closed. Point E, you see, it's unmoved. As point E is unmoved, main valve is unmoved, steam input is unchanged. Okay, because it is this opening is not changing at this point. So you have a new equilibrium between PM and PE. New equilibrium between PM and PE, but omega is still omega synchronous. So that means what would actually change? Your rotor angle delta would actually change. Remember, for higher PE, what you have to do? PE is actually depending upon sine delta. PE is equals to P max sine delta. So delta has to be increased. Okay. In electrical, in terms of rotor angle, we may say the same thing. We may say that actually what is happening with the rotor angle? Because PE is P max sine delta. And P max is a constant for a certain operating point, and delta has to be increased. Delta has to be increased. And for this reason, delta sometimes, other than rotor angle, it is also known as load angle because it has a close coupling with the load. You see, load increased, delta increased, PE increased. Or torque angle. Because of all these reasons, it has different names. Rotor angle in general, or load angle, because you see load is increasing, delta will be affected. Or torque angle, because you are providing more torque. Okay, if load increases, the torque has to be more. The turbine torque has to be higher to supply the higher load demand. So in this way, delta has different names in the literature. Any question? Because we will move on to the next scenario now. But of course, if you understand this clearly, this is the condition, then the remaining scenarios would be pretty easy. Otherwise, it would be a problem. Any question for scenario 1 before I proceed to scenario 2? Please, any question? No question.
No, sir.
Very good. Now let's see how far you have understood. Okay, scenario 2. Now the reverse case, load decreases. Okay, let's start. So load decreases, but of course point A is unchanged. Remember, we are not touching it. Still, we are not touching it. So PL increases. What would happen to the speed? So P would be reduced. Let's say before this happened, we had again 50 minus 50 before load was decreased. So as now load has decreased, let's say it became 40. Now it is already 50. 50 is there. This has reduced to 40. So what would happen? PM minus PE into 1 upon twice H. Again, go back to the swing equation, d omega by dt. So if there is d omega by dt, now this is positive. You see, some positive. So speed would be increase. Oh man, not
Increase.
again.
Increase.
Why should it reduce? You see, it is positive. 50 minus 40, it is 10, right? It's positive. So that means what? D omega by dt is what? Positive, isn't it?
Yes, sir.
So if it is positive, that means what? If in this case, omega was omega synchronous, that means 1500 RPM. Okay. Now what would happen? D omega by dt is positive. That means with respect to time, omega is increasing. So what would happen to the omega? Omega would be higher than 1500
Synchronous.
RPM. More than synchronous, not less than synchronous. Okay.
Yes.
Because this is positive. This means nothing but acceleration. So rotor will accelerate. If rotor accelerates, that means, in other words, omega should be higher than omega synchronous. So this is your shaft speed, point number 1. Shaft speed increases. Clear?
Yes.
Okay, very good. If shaft speed increases, then what would happen? Let's see. Now we have to replicate the things that we discussed, bring back those ideas that we discussed for scenario 1 into scenario 2. Okay, so if shaft speed increases, you see here the symbol, shaft speed increased. What would happen to the centrifugal force? Before shaft speed increased, it was Fc equals to Fs, that there was an equilibrium when it was 50 minus 50, okay, PM minus P. Now shaft speed increased. So if omega increases, Fc would also
Will increase.
So if that increases, fly balls will move apart. You see, spring is stretched. Spring is stretched. Fly balls will move apart because Fc is greater than Fs. Because of this, springs will be stretching outwards in the outward direction. Sorry. So if the fly ball moves apart, what would happen to point B? Point B will go down, right? Because it will pull point B down. This spring stretching will actually pull this point B into the downwards direction. So point B moves down. Okay. If point B moves down, what would happen to C? C is a floating point. It has no other parts attached to it. So if B moves down, fly ball distance increased. Point B moves down. Point A unmoved. Point C moves down. Okay. Again, point E is connected to a heavy shaft, so it will take some time to react to the changes. In the meantime, if C goes down, D will also go down. If D goes down, what happens to piston valve? It goes down. If piston valve goes down, which channel will be opened? The lower channel will be opened. And the high pressure oil will move through the lower channel and give it a force into the upwards direction. Push it upwards. With this push, the piston as well as point E will go up. So the high pressure oil, it actually passes through the lower opening. Point E moves up. Main valve moves up. Steam input decreases. You see the channel is getting, okay, the channel is getting smaller, almost closed. So steam input decreased. Steam input decreased. If
Sir?
yes.
Sir, the air in the upper channel, how can it come out?
Upper channel?
Yeah.
Okay. Upper channel hasn't come out. Upper channel is actually not working because it is closed. Let's go back to the first picture. Let's go back to the first picture. I think everything will be clear, inshallah. We have to always compare. This is the base point, okay? Baseline. This is the base case, steady state operating case, okay? Now, which channel is open?
Both are closed.
Both are closed, excellent. So as because both are closed, actually oil cannot flow in, right? So it cannot pull it down, push it down, or pull it down and push it up. It cannot move it, okay? Because oil force is not working on the main piston valve. So now you see, if this goes down from this point with respect to this specific point, okay? If this whole thing goes down, this piston goes down, which channel will be opened? That means this point will be here, somewhere here, right?
Lower channel.
Lower channel. So thus the upper channel is already closed. There is no other way for the oil to actually move through the upper channel, okay? Because the lower channel will be opened. So the oil will go through this point and it will force it into the upwards direction. Clear? Let me show you again the other diagram where we actually discussing. This is the point. So you see, before the movement, just a minute. Let me bring both of them together so that you can see clearly, just for the time being. Okay. So let me bring them side by side. Probably it would be easier. Remove everything. No need. We'll bring them again back. Now compare it. This is before load increased or decreased, okay? Steady state point, let's say 50 and 50. Now, this point is actually moving down, okay? This whole thing is moving down. So that means, you see there is overlapping, right? I mean, minimum overlapping. These points are just touching each other, these blue parts. So because they're touching, there is no channel. Even though they are simply touching, there is no channel for the oil to flow into this chamber. Okay? When this will go down, what will happen? Their overlapping will be increased, isn't it? Like this. This is not, this hasn't moved yet. Okay, this hasn't moved. This hasn't moved, let's say. So their overlapping has increased here. So there is no way that oil can go through this channel to the upper part. The only way the oil can flow is through the lower chamber. Okay, they were simply touching here before everything happened, before the movement of point D. These both points were simply touching, the lower point and the upper point. Now when the point D moved down, the overlapping between the upper part here, upper blue part, and this main piston increased. But because the lower point was simply touching, it opened. Okay, because of the movement of this blue part into the downward direction. Whole B part is moving down. Whole blue part is moving down. So thus there is an opening in the lower section. Okay. Any question?
Sir, so my question is in picture one, there in top upper portion there is some air. But in second picture, how can it get out? Because if we did not get out from there, how can we give the pressure in lower portion?
We are not giving any pressure, man. The air is giving pressure. Okay, the air is pulling this up and down. Air is pulling this up and down. Sorry, not the air. You confused me. The oil. This is the high pressure oil. Okay. This is the high pressure oil. Sorry, the high pressure oil. This high pressure oil will act on the piston. So whichever channel will be opened, the high pressure oil will move through that region and push it. Because the high pressure oil cannot go away out of this chamber. Okay, there is no way it can go out of this chamber. So once it flows through the channel, there is only one direction the force can be applied. And that in this case, it is only in the upwards direction. So you are talking about air. You can only see the diagram. Probably you are seeing that there is air, right?
So actually, my question in first step, when we put it down, so, we need to give some oil pressure in top portion. But when we put it up, so what happened to previous we give the oil in previous step?
Oh, that's why I said that if you have any question, please ask. Probably you are talking about this slide.
স্যার অ্যাকচুয়ালি আমাদের প্রথম স্টেপে যদি আমরা উপরের পোর্শনের ওয়েলটা এন্টার করি, তো আমরা পিস্টন নিচে নেওয়ার পরে উপরের পোর্শনের ওয়েলটা আউট হওয়ার কোনো ওয়ে তো নাই। যদি উপরের পোর্শনের ওয়েলটা আউট না
No,
হয়,
no, 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 no. This oil will actually come out of the chamber. Once it pushes it, presses it, then whatever opening is, even a small opening is there, you cannot make it actually that tight. Okay, there are some space for the oil to actually flow in, and probably it will come out like this. You get it?
ইয়েস স্যার।
It's not like that is actually a very tight, such tight that the oil actually cannot flow through it in any manner. Okay, but the channel is not such open that well, it is a high pressure oil and it's going simply through it like this out of the chamber. Not like that. Its job is to simply take the energy and transmit it to this heavy piston so that it moves down or up as per the direction of force. Okay.
ইয়েস।
Okay. So where we were, this was that part that we were discussing. Okay, so let's leave it. Okay. So where we are. So okay. Okay, Tafim, are you talking about that well? I don't know what you asked about. Okay, let me again check with you. So are you talking about this thing that if the oil goes like this, then how would it stay there like that? Is it your question?
নো স্যার, ফার্স্ট স্টেপ প্রথম স্টেপে যদি আমাদের উপর পোর্শনের ওয়েলটা এন্টার করে, তো যে আমরা যে ডিটা নিচে ডাউন করার পরে উপরের পোর্শনের ওয়েলটা বের হয়ে যাওয়ার জন্য ওইটা তো নাই, ওইটাই জিজ্ঞেস
Oh,
করছি।
that way. Okay, well, that way is there actually. That way is there. Probably the drawing is not that much accurate. Okay, that way is there for the oil to leave the chamber. Don't worry about that. Okay, that channel is there. Okay. Because it is drawn by myself. Okay, it is not taken from any book. So probably the scaling, it is not up to the scale. Okay, it is not drawn to the scale. There could be some small errors, you can say, of minuscule nature, so that you are having a question like that. Okay, so we are talking about scenario 2, right? Not here. We were not here. We were here. Scenario 1 was done. Scenario 2. Okay, so once the pressure is there, so the piston will move up. This channel will get closed, and because of that, where we are. Okay, so because of that, ultimately what will happen? Your steam input will be decreased. Steam input will be decreased. So if steam input decreases, remember initially this shaft speed increased, right? Shaft speed increased. So if steam input decreases ultimately, that means your PM, okay, we started from generator load decrement. So PL decreased, that made PE decreased. So now ultimately we see steam input decreasing. So that means PM is decreasing. So whatever increase in the shaft speed was there initially, now because we are having a new balance between PM and PE, so the speed will again, okay, let's say when the speed increased initially, again it is, let's say 1580 or 1600, something like that, whereas omega synchronous is 1500. So this was the difference. Now speed, because of steam input decreasing, we will have from 1580, the speed will slowly come back to 1500 again. So that is equal to the omega synchronous. Okay. So what's next? So now this is the continuation of scenario 2, as we said in the previous case, continuation of scenario 2. So now still the set point remains fixed. The shaft speed now, as I just said, it would decrease and it would get settled, of course, to the steady state equilibrium, that is the synchronous speed. What would happen to delta? Anyone? The rotor angle? Omega is equal to omega synchronous. PM getting reduced because PE got reduced. Why? Because there was less demand. Load demand was less. What would happen to delta?
Synchronous speaking.
Huh? Delta, not omega. Omega is omega synchronous. That's fine.
Will reduce.
Yes, delta will reduce because Pmax for a certain operating point, that means Pmax is simply E prime V by X equivalent. Okay, E prime is the, unless you change the excitation, E prime is a constant. V, of course, it is for the simplified machine model, okay, not like as we took. But even then, you can make PE as a function of delta, okay, maybe a nonlinear function of delta. So it is a close relation with delta, okay. So as I said earlier, because name of delta is also the load angle. So as load is decreasing, simply we can say without thinking too much about this expression, if load is decreasing, that delta should also decrease. Because if you remember, probably in your undergraduate course, the PE delta curve following this relation over here, P max sine delta looks like this. Okay, looks like this, where the maximum reaches when delta equals to 90 degree. This is the power angle curve. Okay, so delta would actually reduce. So system will settle down to an equilibrium with reduced delta, and the generator will be delivering reduced electrical output. The turbine torque would be reduced. So as the shaft speed is getting reduced, what would happen? Spring. Remember in the previous case, spring stretched. So now spring will do the opposite. Spring will compress back to its normal position. Fly ball distance will become what? Fly ball distance will be reduced. Actually, spring will be compressed. Fly ball distance will be reduced. Okay. Point B, what will happen to point B? Because the fly ball distance are getting reduced, these fly balls are getting closer. Point B would be moving up. Either you can say compressed back or reduced, because compressing actually is related with the spring. Okay, fly ball distance is actually reduced. That would be more appropriate. Point A is still unmoved. Point C, okay, point B moves up. Point A unmoved, so point B will pull point C into the upwards direction. Point C moves up, it will move point D in the upwards direction. Piston valve along with point D, piston valve will move in the upwards direction. Channel is again closed. Okay, channel is again closed. So because there is no pressure again, no further pressure from the high pressure oil, so point E is unmoved. Main valve is unmoved, steam input is unchanged at a reduced value. See, the channel is getting smaller compared to the previous steady state operating point. That means you have reduced PM available, which can supply reduced PE, as that also means reduced PL. Okay, any question? Any other question? Now we will move 6 minutes. Okay, let's take scenario 3 and then probably we will stop, because scenario 3 will help us to understand scenario 4 quite easily. So scenario 3, we will, as I said earlier, scenario 3 would be now what we will be doing. We are not touching the load anymore. From scenario 3, starting from scenario 3, what we will do, we will keep the load constant, but the set point is lowered, means point A is lowered. Okay, you see point A is lowered. Okay, so now let's get into it. So if point A is lowered, to start with, the shaft speed is fixed. Okay, at this point, load is not changed, remember. So the shaft speed that is sensed by this part is still omega synchronous. So this is the difference between the previous two scenarios. Okay, because we are not touching the load, load is fixed, but we are touching the set point now. Set point is lowered. Okay, now because B is the pivot point, okay, set point is lowered and it is fixed at this new point. Okay, so point A is lowered, we can say, and fixed at a new position. That would be better to write. Okay, that means we are again, after lowering, we are again keeping it fixed. We are not moving it anymore. After changing, after the initial movement of point A, it gets fixed. Okay, it gets fixed to a new position. That is in lower position compared to the previous. Previously, it was here. Point A was here. Now it moved down. It is moved down and then again fixed. Now the pivoting action, because of the pivoting action of this arm ABC, point B would be fixed. Point B would be fixed. Remember, point B is fixed. Point C, now due to the pivoting action, as A goes down, C will go up. Clear? B is unmoved. B is unmoved. C is moving due to the downward movement of A. There is upward movement of C. Okay. So because the speed is not changing, let's look at let's look at the scenario. What is happening here? The lower part. Fly ball distance. Will it be changed? Fly ball distance will not be changed. Okay. Still, FC equals to FS. Steady state operating case. FC equals to FS because speed is fixed. So the fly ball distance will remain fixed. Shaft speed is remaining fixed. Point B is remaining fixed. Point A going down, point C going up. B working as a pivot point now. What about point D? Well, with point C, point D will also go up. If it goes up, the upper channel opens. Piston goes up. Point D goes up. High pressure oil comes through the upper channel and tries to push it down, push it down. So if it goes down, point E will go down. Point A goes down, main valve goes down. And that will create higher steam input. Okay, steam input increases. Steam input increases. Okay, so if steam input increases means what? We are increasing PM, isn't it?
Yes, sir.
Okay, so what I said, if we lower this set point, we have a raise in PM. Okay, reference power. Reference power is, if we lower point A, you see, if we go to the first slide, I mean slide number 12. By first slide, I mean the first diagram. You see the lowering and raising symbols, reference setting. So according to this diagram, if point A is lowered, okay, point A is moved down, then you have a raise in the reference, raise in the mechanical power set point, PM ref. You get it? You are getting a new reference point. So by changing point A into the downwards direction, moving point A towards the downwards direction, you can increase your PM ref, PM set point, mechanical set point. Okay. So scenario 3 actually describes that. This raise actually means raise in PM. Okay. So this raising is possible if you lower this point A. This lowering means reference setting lowering. That is possible if you take this point into the upwards direction, move this point into the upwards direction. Okay. So this is scenario 3. Let's again come back to scenario 3. So yeah, set point lowered. So steam input, set point lowered, high pressure. What is this? Probably this is, yeah, this is the first slide. Sorry, we were here. Okay, so this is scenario 3. Steam input increased. So this is where we stopped. Steam input increased with lowering of point A. Steam input increased. But now the scenario hasn't finished. Okay, the actions hasn't finished yet. It will continue a little bit more. Why? Because you see, by increasing PM, what we are doing actually, by increasing PM, we are creating another imbalance between PM and PE. Previously, in scenario 1 and 2, the imbalance initiated from PE or PL. In this case, in scenario 3, actually the imbalance will be initiated by PM. In other words, by the movement of point A. So as we are moving point A, we are actually changing PM. And as soon as we are changing PM, that would affect this balance between PM and PE, which is d omega by dt. Right? So now by lowering point A, we are getting more PM. This balance will be disturbed. This would now give me some positive value. So what would happen to the shaft speed?
Increase.
Increase. Excellent. So as the shaft speed increases, that increase in shaft speed should be sensed by what? Which part?
Fly ball.
Actually, yeah, the fly ball mechanism. The fly ball mechanism will actually sense it. Okay. So now let's try and finish this scenario 3, and then we will inshallah stop. So now you have moved to scenario 4. This scenario 3 second slide. Yeah. So scenario 3 second slide, it says, well, it's still point A. Now point A is unmoved. Okay. Point A, we moved it initially in the first slide for scenario 3, that is slide number 17. In the second slide, we are not moving A anymore. Remember, we moved it down, but then it was set fixed at that new position. So now speed will be increased, as I said. Okay, speed will be increased because steam input increased at the end of this scenario 3, the last point here in slide 17. Steam input increased, so shaft speed will be increased. Shaft speed will be increased. So this is increased. Point A unmoved. Fly ball distance stretched, the extended. Okay, because of shaft speed increased, what would happen? Your centrifugal force would be higher than the spring tension. So spring will be stretched. Because of this stretching of the spring, point B will move down. Point C will also move down. Point D will also move down. Then when it moves down, then piston valve moves down, channel gets closed. channel gets closed. Did we discuss this previously? Oh, we actually didn't finish it. Okay, sorry. We have something left still. We only said that steam input will be increased, right? Steam input will be increased. We actually didn't finish it. Okay, let me finish it. Sorry. So we said up to this point actually. Then actually we moved to the speed and PM and all other things. So as point A was lowered, point C will be moving up, right? Point C will be moving up. Point D will be moving up. As point D is moved up, this will, so upper channel will be opened and this shaft will be moved down. So your steam input will be increased. Remember, we have upper channel opened and then steam input increased. So with this increased steam input, we are now here. So what would happen next? Steam input increased, so shaft speed will increase. Fly ball distance will be increased. Because of that, point B will go down, point C will go down, and point D will go down, and that channel, upper channel which was closed, will become, sorry, that was opened, upper channel in the previous slide, now it will become closed, and accordingly, there will be no further movement of point E. So channel gets closed, point E unmoved, main valve unmoved, steam input now remains unchanged, equal to the previous value of scenario 3. So this is the discussion up to scenario number 3. In the next class, inshallah, we will continue with scenario 4 and some mathematical derivation for the modeling part of the governor, okay, under discussion. So at this point, at this operating point, what is the conclusion actually? Can anyone tell? What is the conclusion?
So load and the mechanical load and the speed of the shaft, they are related. Like if one is changing, then this mechanism is controlling the other one.
Yes. So actually what we are doing, we are simply discussing the control mechanism, the background control mechanism for the steam flow and the PM, how they are related. But my question is actually, you see, at the last point, even at the last point, what we are getting?
Increased speed.
Is increased speed. We are getting increased speed. Okay.
New synchronous speed point.
New synchronous is there. Synchronous speed cannot be new. Synchronous speed is always synchronous. Okay, we will discuss. We have already crossed our time. So inshallah, next class, we will see how to deal with this. Okay. What is actually happening with the increased speed? We have got high steam input, PM. Okay. So that, okay, let me finish it. Otherwise, it will remain as a big question for you. So what that means now, okay, what it means, now you are actually in a position to supply more PL. This is the conclusion. Okay, this cannot continue for long. You get the idea? This is not an equilibrium scenario. Okay, shaft speed increased means what? Is increased from the synchronous value. So this increase would be, let's say, something like 1600. So by lowering this point, what you are doing actually, you are putting yourself in a position where you can supply more demand. Okay, by changing this set point. So now you have more steam available. You have more steam available for supplying more demand. Okay, So this is how you can translate a bridge. So that means instantaneously, if you have okay, I think I should stop here. Okay, so already 10 minutes over. So by this, actually, we can have, we will be in a position to supply more demand. Okay, and once that demand will be there, then you will see that ultimately this increased speed will not sustain for long. Okay, this would again come back to 1500. Now speed is increased because you have more PM than PE, isn't it? So when the PE will be increased,
Yes.
then this imbalance will be vanished, and again the system will come back to 1500 ultimately. So by increasing the reference set point, you are allowing yourself to supply more demand, more electrical demand. You will be in a position to supply more electrical demand. Okay, this will not sustain for long. Okay, this situation will not sustain for long. So as soon as there will be any load available, increased load, you will be able to supply it from this high steam input, available input. Okay, so now about the next class, I have a departmental meeting on Monday exactly at 7. Okay, so I don't know whether I would be able to continue with the class on Monday. And Tuesday I have regular meeting. So if you agree, then we can take it on Wednesday.
Sir, Wednesday I have a class.
Wednesday you have a class. Okay, then let's meet on Friday, inshallah, again. Okay, Friday, what time? 8 a.m.
8 a.m.
Okay, okay, inshallah, 8 a.m. Okay, then see you then. Assalamu alaikum.